Hi, this is Bob from INSYDIUM. In this video we're going to explore the Nexus nxConstraints modifier. We'll use nxConstraints to connect these particles. This works like springs. We'll explore how to break those connections, which gives us this tearing effect. And then we'll introduce more Nexus modifiers to get the final look. So let's build this scene from scratch so we can all follow along. So first of all, we need to make our animated sides, and we'll just use a primitive cube to start that. So in this primitive cube, let's have a look at these dimensions. Well, it needs to be kind of long and thin, really. So we'll make it, let's say, 2000 centimeters in the Z. The height, we can keep that at 200, and we can just make the width a little. Let's make it a bit narrow. We'll put maybe 50. Okay, that's looking good. Let's hit ND so we can see the lines, hit the polygon lines. That's the shortcut menu. You've hit N. Here we have all of our different shading options, and then D was quick shading lines. You can access those same menu and options if you go to our viewport display menu, and here look, we can select these different shading options. So we wanted ones with lines, either quick shading lines or Gorad shading with lines, and it just means that we can see how this geometry is made up. Let's add some more divisions to this. We'll go to our cube, and in the Z segments, let's put this up to maybe 30, and then Y segments, we could have 5, and then X segments, let's put that on 2. Okay, so now we've got some geometry in this cube, and we'll start just by animating one, and then we'll just flip it, which will give us the two kind of breaking apart. So let's go to our cube, to our coordinates, and on the x-axis, let's just move this out so it's starting at a position of 150 centimeters. And on frame 0, we'll hit a keyframe on that. And let's actually add some more frames to our scene. So let's put this up to maybe, I don't know, 500 frames. And then we'll move forward to, we want this to kind of reach its maximum pull apart stretch at about maybe frame 180. So let's do that, and then let's increase this by, well look, if we increase it by 500, it'll reach 650. So let's try that. Okay, so then we're getting this animation. This is going to be pulling our particles out, but we want a bit of rotation in there as well. So on frame 0, let's hit a rotation. We're going to be animating this heading rotation here. So let's put that back down to 0, and on frame 0, we'll add a keyframe. Then kind of halfway in between, maybe frame 93, let's just add a bit of heading rotation like this, so it's kind of stretching outwards. Hit the keyframe, and then we'll go right up to frame 180 again and 0 that back out to that. So those two keyframes on our angle and on our position mean that we get this animation on our cube. That's looking cool. So obviously we want to double this over. So what we will do is, let's just call this one cube right. And then we'll hold Control, drag it down to make a duplicate. Let's just change the name of that one straight away, and we'll call that one cube left. And all we need to do here is flip around these values. So on frame 0, instead of it being 150 centimeters, we want that to be minus 150. And let's hit a keyframe, so that's recorded. On frame 180, instead of it being 650, we want it to be minus 650, and then hit a keyframe. So there we've got our position mirrored, but our angle isn't working properly because we need to flip that one as well. So let's go to our frame where we made the angle adjustment, and on the cube left, it wants to be minus 10 degrees. Minus, hit a keyframe. So now we've got our two bits of geo, and they are animating outwards in unison. And this is going to be our bits of geometry which we'll use to pull and stretch our particle netting apart. So that looks good. Just so we can kind of ignore these. We want to see these in the viewport, but we don't want them to be quite as prominent. So what we could do is, look, let's go to our material manager here, double click to create a new material. Let's stick it on both of those cubes, and we'll just make some adjustments to this material. Let's double click to open the material editor, and we'll switch off color. We'll go to reflectance, and we'll switch off this default specular layer. Switch that off, so now there's nothing, it's just black. Let's add a Beckman, which is going to be like a shiny reflective layer. So you can see there we've got our shiny material, and we want this to be dark, so let's go in that layer 1, let's come down to the layer color and change it from white to a very dark grey. Okay, switch that off, close the material manager, and now we've got these kind of shiny reflective materials. We can get rid of viewing these lines in the viewport now. Let's go to display and just put Gorad shading. And we could get rid of this work plane here. We don't need to see this grid. So let's go to filter and let's deactivate work plane. And there we go. So we've got our shiny pull apart bits of geometry, which are going to stretch our particle net. Great. So now we can get on with building the actual particle scene. So let's bring in an nxParticles system. We'll go to our INSYDIUM menu. We'll bring in an nxParticles system, which is our organizational hierarchy. To keep things organized, let's take our cube right and left and move it into our utilities folder. And then we'll just close that up. That's nice and organized. So you can see by default we have an XP emitter that's been brought into our scene. And if we just come in a bit, you can see it's a square emitter. And if we hit play, we're blasting these particles in the +Z direction. That's the default settings. But we don't want that. We want to create a grid of particles, like a mesh of particles in the gap of these two collision objects. So to do that, let's go to our emitter, to the Object tab, and we're going to change the emitter shape from rectangle to box. There's our box. And now what we're going to do is we're just going to, what we could do, in fact, we could go to the top view. So let's go to view in the camera menu. Let's go to top. So now we're having a top-down view of our box. And now we can adjust the dimensions. Let's take the width of this box. And what we want it to be slightly wider, so they're jutting into the inside of our collision geometry. And that's how we're going to get our particles to stick to the inside of this as they're pulled apart. So that's that. Let's just move out a bit. Then we can make the length much longer, something like this. Okay, let's go back to cameras, back to our perspective view. That's good. Now we can look at how tall this emitter is. Now it doesn't need to be very tall. We want a thin mesh. So we'll bring it down something like that. So we'll leave it at that for now, but we may make some adjustments. So now what we want to do is, if we hit play, we've just got particles firing off from the faces of that box. That's obviously not what we want. We want to shoot particles out on one frame, and we want them to be static. So let's go to our emitter, to the emission tab. And we don't want the emission to be rate. We want it to be shot on the first frame, and the shot type random. If we, let's just come a little bit further down, take all of this default speed off to 0. So now if we hit play, we're getting particles shooting out on one frame, but they are just randomly positioned within the volume of our box. And we actually want a really regular grid. So to get that, we're going to actually use one of our fluid emission modes. So with emission set to shot, we can go to the shot type and change it from random to hexagonal. And if we go forward a frame now we have this perfect grid of particles. And what hexagonal does, it uses the particle radius and it fits as many particles as possible within this perfect hexagonal grid based on the radius. So if the particles are bigger, let's put, say, a radius of 6, obviously the grid is going to be bigger. There's going to be far fewer particles, there we go, in this grid. Now, let's put that back down to, let's just put it down to 5. Now you can see with a radius of 5, we're only getting one layer deep, tall of particles. And that's because our emitter just isn't big enough to be able to fit more. So we want about 3 layers of particles in the vertical. So let's just take this handle of this emitter and make it a bit taller. Now Go forward a frame. Right, so look, now we're getting some depth. We've got about 2 or 3 particles. Okay, excellent. So there is our grid of particles. They're static, and if we hit play, obviously nothing happens because there are no forces affecting these particles. They have no speed. They're not attached to each other. They're just living independently in 3D space. So now we need to set up getting them constrained. And just before we do that, let's just bring some movement in here. So we're going to go to our Nexus menu. We're going to bring in a Nexus modifier to move these particles around. So let's go to our objects list, and we're going to bring in a nxTrubulence. And when I bring this in, have a look. Our emitter, which by default is set to the CPU mode, which is the blue icon, it's automatically going to switch to GPU, which is orange, when we bring in this Nexus modifier. There's no need to hit a GPU button or anything like that. This is all done automatically. So let's bring in an nxTrubulence. The emitter goes orange. This is now calculating on the GPU. And if we hit play, our particles are going to start animating with this turbulence. Now, these particles aren't connected with each other. They don't care about their neighbors. They are just being forced around by this turbulence. So let's just adjust it slightly. We'll increase the scale. Let's move from this simplex, which is a kind of a default noise, a simple noise, to something like turbulence. And let's hit play. Slightly bigger scale. Okay, so now the particles have some movement, but as I said, they don't care about each other at the moment. We need to connect them together, and we're going to do that with some constraints. So let's go to our Nexus menu and have a look in here, and we want an nxConstraints. Let's bring that in. Now, our nxConstraints, this one object can do lots of different types of constraints. It can do connections, which is what we're going to look at today, which is connecting particles with springs. But it can also do particle-to-particle collisions. It can do forces, which gives particles forces of attraction and repulsion. And then it can simulate fluid stuff like viscosity, friction, and surface tension. So all of these can be done within the same object, and you can have multiple layers of constraints in this node graph here. But for us, we just want to connect these particles together with springs. So let's just click on the connections type, which are the springs. And there are, let's just move this up a little bit. There are 3 different types of connection constraints. We have birth connections, which is self-explanatory. They're created on particle birth. We have distance connections. So these are dependent on how close particles are to each other. And then we have custom connections, and these work in the same way as distance. It's how close they are with each other, but there are more advanced settings in the custom ones. We're not going to be looking at distance or custom today. We just want to do birth connections. So we're going to be using the birth tab, and to activate the birth controls in this one, let's just click on the B. So now these are birth constraints. Excellent. So what we have are, as I already said, is that the particles are connected together with springs. And we're able to view these springs by altering one of the particle display settings. So let's do that. We want to have a look at these springs and see what they look like. So let's go to our emitter, to the display tab. And here, look, we have a display constraints button. So if we click that on, now if we go forward a frame, what's going to happen is, look, we've got all of these yellow lines. Let's move in close. And there we can see, look, our grid of particles have been connected by these yellow springs. And these are our constraints. So how have these been formed? Well, let's go back to our constraint settings, to our connections. And there aren't actually that many settings. So first of all, let's have a look at this radius value and the connection limit. So what this is saying is, any one particle is able to connect to up to 8 other particles with a spring, but only if those other particles are within this radius of 40 centimeters. So if we reduce this down to just say 2, now any one particle can only connect with 2 others within this distance. So let's resim, and look, yeah, it looks completely different. Let's put this up to, I don't know, let's try 12. And now I've got even more constraints because any one particle is able to connect to 12 other particles with 12 springs as long as they're within our search radius here of 40 centimeters. So then we're able to adjust how stiff the springs are. And if we just move back a bit, we can now play this. And because our turbulence is going to be moving our particles around, but then our springs are going to be trying to hold them together. So we've got some kind of forces fighting against each other here. So let's hit play and just see what happens. So yes, look, we've got this net of particles that are moving, and then some bits are breaking off. So why are some bits breaking off? Well, that is suggesting that the constraint has snapped. And that's because we have these breaking settings, which can do just that. If we come down to our connection settings again, you can see, look, by default, we have break type set to relative connected, and then we have this percentage. So we can just switch off them, so none of these pieces fly off. Let's just change this to none, so there's no breaking at all. Hit play, and now we have these particles attached by these springs. And if we reduce the stiffness of those springs, they'll be able to stretch a lot more. And now we're getting much more stretching in those particles. So now we understand that these connections are springs. We don't need to view them anymore. Let's go to our emitter, to the display tab. Let's switch off the display constraints. Now we just have some particles. And let's change these particle display type so it looks a little bit more interesting than this flat blue. So we'll make a couple of adjustments. First of all, let's switch off, so we're in the emitter display tab here. Let's switch off draw emitter. We don't need to see this orange bounding box, so switch that off. Let's change our display type of our particles from squares to dots. Let's change the color mode from single color to gradient parameter. And that enables us to map this gradient to our particles based on things like speed or distance travelled. So let's change it. At the moment, the gradient parameter is set to age. So when the particles are born, they're dark blue, and as they get older, they gradually get lighter blue. That's not what we want. So let's change that from age to, let's do it to speed. We'll put the speed on, say, so the minimum speed on 0 and the maximum speed on 200. So that's saying that when a particle isn't moving, it will be blue. And when it's moving 200 centimeters per second or above, it'll be white. And anything else will be somewhere in between. So if we hit play, we'll see that happening. We could do with increasing the particle count now we've got this set up. We want more particles in this scene to give us more detail. So to do that, we'll go to the particle emitter emission tab. Let's reduce the radius of those particles down, which means that our hexagonal grid will be smaller, so we'll have loads more particles. Let's put it on, say, 2. So now we've got a huge amount of particles being moved around. This turbulence is a little too strong, so let's go to our turbulence and reduce that strength down to, say, 1. There we go. So at the moment, they're just being moved by the turbulence, and what we actually want to do is stretch them using our collision geometry. So how might we do that? Well, it's pretty simple. We just need to convert these bits of geometry into x-particle collision objects, and we do that just by sticking a tag on them. So let's go to our utilities folder, and we have our cube right and left. Let's just do the right one first. So let's select it, go to our tags menu, INSYDIUM tags, and we want an XP collider. Let's click on that. Now by default the normals are set to outside, so it's saying particles will only collide with the outside of this object. But if you remember, we trapped some particles inside here, and we want them to stay stuck inside, so when they're moved backwards they stretch our mesh. So we actually want inside. Let's add some friction so they kind of are sticky to that surface. And now let's hit play and see what happens. So now look, they're pulling it back. and then they're stretching and springing backwards. Now look, our constraints are far too springy at the moment. They're being able to stretch too much. So let's go to our constraints, and we've got our stiffness way low. Let's put this up to, say, I don't know, 91%. And now they're not going to be able to stretch as much. And look, they're not stretching as much. It's pulling it back. It's still stretching a considerable amount. Now, if you're using constraints and they're not as stiff as you want, and you're maxing out the stiffness, then the only way to make them more stiff is to increase the simulation accuracy. And to do that, all you do is go to the constraints object, and we can increase the iterations here, which will increase that accuracy. So if we put this on, say, 3, you're going to see that these constraints now are going to be much more tight. Look, they're not stretching as much, and we're pulling these back. And the turbulence isn't having as much of an effect because those springs are tighter. And then look, they're snapping back. Now, when they snap back, they're now being able to intersect this collision geometry. And that's because we set the normals to the inside. So it would be cool if it would do both. And we're able to do that. Let's go back to our collision tag. And instead of it normals inside, let's set it to any. So now we're going to get this pulling our particles back. The ones inside are trapped because of our collision tag with the inside normals. But then when these springs snap back, they're going to bounce off the outside of our collision geometry. So that's looking very neat indeed. And this is simulating incredibly quickly. If you think of how many particles we've got in our scene, and each particle has got 12 springs attaching it to every other particle, and still we're getting this incredible viewport performance as this simulates. And this is because this is the power of Nexus, and we're utilizing the system GPU to get this simulation to run this quickly, and it's looking fantastic. So now we've got that, let's kind of activate the collisions on our left-hand collision object. And to do that, we just need to copy this tag across. Let's hold Control, drag this down, let go. So now both of them have got a collision tag. Let's hit play. And now look, we're pulling and stretching this apart. We've got excellent viewport performance here, look. And that's animating really nicely. So now we've increased the stiffness of this and the simulation accuracy. We could increase this turbulence strength a bit. Let's increase that strength so we can get some stronger kind of rippling going on. There we go. Perhaps slightly too much turbulence, but that's looking very interesting. What we could do, we've made some nice kind of big ripples with our turbulence here. If we wanted to retain those big ripples, but add a little bit more fine detail as well, we're able to use the fantastic persistence and octave controls in our turbulence. So what we can do, if we increase this octaves, this effectively makes more detail. But because it makes more detail, it's going to make it look like a much finer turbulence. Look, you see how much detail there is in there. And what we're able to do is flatten out some of that finer detail by just reducing this persistence down. And what this does, it kind of fades out the strength over the octaves. So the early octaves have a lot of strength and the later octaves have less strength. So if we put that down to, say, 50, we can hit play. And then there, that's looking very cool. That's very nice. Now, I don't think we need quite so much turbulence in this scene now. So let's put that back down to 8. And then we can start looking at our braking controls. And obviously you can play around with that turbulence setting to get the look that you want. But that's looking very nice indeed. So now let's say that we want this to break. We want it to snap. So let's go to our constraints settings. And we can have a look to our brake type. So let's have a look at the easiest one. The easiest brake type to understand is absolute. So if we click on this, then we get this. Let's just bring this interface down a bit. Then we get this brake above attribute. And all this is saying is in absolute mode, if the spring stretches to above this value, 60 centimeters, it will snap. Now, this is quite a small scale scene. So my guess is that we're not going to get any snapping They're never going to stretch to 60 centimeters. Let's have a look. No braking just yet. No, it's not happening. So let's go lower down. Let's try maybe 25 centimeters and resim. Let's see, we're getting any braking. Yes, a little bit here, some braking down the middle, and then yeah, we get like a ripple effect and lots more braking as the connected ones kind of push and pull each other around. That's looking very, very cool indeed. So instead of our brake type absolute, we can also set it to, there's a couple of relative modes. Let's use relative connected. So instead, bear in mind, when we're using the absolute mode, any constraint, as long as it stretches above that absolute mode, it'll brake. But some of these constraints are different lengths when they're born, depending on which particles they're connected to. So instead of having that kind of universal absolute brake threshold, it can be relative, dependent on how long the original constraint is when it's born, when it's created. So this is saying that, let's put this on, I don't know, say 300%. This is saying that if any one constraint stretches to within 300 to over 300% of its original length, it will then brake. So it's relative, it's dependent on the length at birth. So it's a little bit more subtle, this one. So let's have a look. And look, we've got some braking earlier on here, look, along these edges. And then we get some in the middle, so that's very cool. And obviously we can make adjustments. We can make that a little more. Let's put 350, so they're not quite as easy to brake. It's got to stretch a bit more before they brake. That's looking good. They're holding themselves a bit and then braking in the middle, so that's looking really nice. So that is the basics of how to set up our birth connections with braking to get this really nice netting effect. And the fact that this is running so quickly is because it's on the GPU. This is a very computationally heavy operation going on here, but we're getting this amazing viewport performance and speed because of the power of Nexus. One last thing to do with this is I'm not happy with this strength of turbulence at the beginning of the sim. And so we could perhaps keyframe that turbulent strength so we get more of a nice initial stretch without this turbulent movement. So let's go to our turbulence, and by the time we get to this amount, this frame, we want our turbulence. So let's, at frame 81, keyframe that strength of 8, and then say frame 40, or well, we're on frame 36, we'll put this down to 0. So it's going to start at no turbulent strength. We're going to get a bit of a stretch, and then the turbulence is going to bring in, yeah, that's looking much nicer. And there we're getting this fantastic look, all simulating. So we're able to art direct this with ease in the viewport, even though it's a very computationally intense sim, which really demonstrates the power of Nexus. Let's just try increasing our particle count. We'll go to our emitter. We're on 2. Let's put this radius on to 1.5, which is going to increase the amount of particles considerably. It's going to increase the amount of connections considerably. And look, we're still able to get this really good viewport performance. Now we've changed our constraints, we need to adjust our braking limits. So let's go to our constraints and our relative. Let's put this up to say 400% now. See if that's fixed that. They were braking a little bit too quickly for my liking. And yeah, there we go. They're holding on a bit, starting to get some breakage. And that's breaking through the middle, and that's looking great. And look, we're still getting this fantastic viewport performance as this simulates through. And this is the exact technique that we used to set up that constraints in our render.